Okay, so we looked at vertical asymptotes, now horizontal asymptotes. Okay, so this is actually a little bit easier because it's more of a visual thing to look at. Right, so again, remember this? This had a vertical asymptote, remember? X can't be 3, so we did have a vertical asymptote. It's hard for me to draw down here, okay? Vertical asymptote. Okay, look back at that one previously. Now look, it's also got a horizontal asymptote here. Okay, it is the x-axis, which is y equals 0. Okay, so this has a horizontal asymptote, y equals 0. Now, we can actually show that later, but I should give us a few more examples, okay? Right, horizontal asymptotes. So again, they're kind of similar to rules what I showed on the vertical asymptotes. Okay, let's have a look at this. As x, let's get my arrow up. As x tends to infinity, then you see y, or f of x, is heading towards this line b, whatever this number is, okay? As x tends to negative infinity, it's heading towards this line b, okay? And same on this as well. So really it's just showing you as x tends to infinity or negative infinity, the graph is tending towards that horizontal asymptote, okay? Examples, right, I'm going to look at this one here. Okay, now I'll do the general rules shortly, but look, the horizontal asymptote of this is going to be 3/2. And what it is because these are the same exponents, okay, the leading term for both is x squared, it's just 3/2. And here it is. Here's the horizontal asymptote at 3/2. Now do notice here, look, you can actually cross a horizontal asymptote. Remember, you cannot cross a vertical because x, for this one, x cannot be 3, so it can't touch it. But with horizontals, there is a chance that you can cross it, so remember that when you're graphing. If you feel the need, you have to cross it, you can cross a horizontal. Okay, so the horizontal asymptote for this is 3/2 because of this leading exponent. Okay, let's have a look at the next one. I can see for this one then, look, okay, x to the fourth, the horizontal asymptote is going to be negative 7/11. Okay, there it is, negative 7/11. It's just there. So I'm going to show you the general rules. Look at this. When the numerator and the denominator of a rational function have the same degree, again, let's go back to this one. Same degree. Okay, the horizontal asymptote is just 3/2. Okay, leading coefficients. It should say so there. Okay. When the degree of the numerator is 1 less than the denominator, then it's just y equals 0 for the horizontal asymptote. And if I go back here, let's have a look. Look at this one. See, that denominator is a degree less than the numerator. Okay, and that's why the horizontal asymptote was just y equals 0. So again, have a look at this one. There you go. Here, the horizontal asymptote for this will be y equals 0. Okay. Again, the denominator 1 more than the numerator, or the numerator 1 less than the denominator. Okay. And again, if I had something like 4x squared plus 3 over 2x squared minus 5x plus 2, something like that, then the horizontal asymptote would be 4/2. It would just be y equals 2. Okay, for that one. Now, when we have it where the degree of the numerator is greater than the degree of the denominator, there isn't a horizontal asymptote. We'll be looking at oblique, okay, asymptotes later. Instead of a vertical or a horizontal, we'll have an oblique. There you go. So, that's horizontal asymptote.